I'm just going to cut out the beginning. Hello, class. How are you this afternoon?
Good.
Can anyone tell me what a coordinate plane is? Yes.
It is a graph that has a horizontal x-axis and a vertical y-axis.
Right. A coordinate plane has an x and a y axis. As Kathleen pointed out, the x-axis is what?
Horizontal.
Yes, the x-axis is horizontal. Can you show me horizontal? Like this? Yeah. Very good. Now the y-axis is what?
Vertical.
Very good. The y-axis is vertical. Can you show me vertical? Awesome. Does anyone remember what we did with coordinate planes?
We put points on it based on the numbers given.
That is correct. Way to go. We were given a point. Can anyone tell me what a point is? Anybody?
A point is a location in the coordinate plane.
Great job. That is exactly right. A point is a location. Can anyone give me an example of a point?
2, 3.
An example of a point would be 2, 3 in parentheses, and it would look like this. 2, 3 in parentheses.
Oh yeah, forgot those.
Yeah. Okay. So, would you like to put that coordinate point on our graph? Remember, you've got your x-axis here, your y-axis here.
Okay, so 0 is here.
Mm-hmm.
And the first number is the x,
Yes.
so that would be here.
Mm-hmm.
And the y is going to be 3. So that would be 2, 3.
Great job.
Cool.
Okay. Now, do you put another point on the board?
Sure.
Okay.
In a particular point?
Well, let's see. I'll put it, okay?
Okay.
I'm going to pick 4, 6.
Okay.
It's right there, okay? Now, does anybody remember what it's called if I were to draw a line between these 2 points?
A segment.
Yes, a line segment is a line connecting 2 points. So, there's our line segment. Now, does anybody remember how to find the slope of a line segment?
You use the rise over runs, so for that problem it would be 3 over 2 because you have to rise 3 and run 2.
Close.
Oh, no, that was for the other one. For that one, it's going to be rise over run, so it would be 2 over 2.
Which is?
1.
Right, so the slope is 1 because I could put a point here at 3, 5, I guess that's 3, 4, and it would still be at 1, okay?
Okay.
Now, let's pretend that we live in this city, okay? We're going to call it Taxicab Land. Now, look at this map right here. It's this one.
Mm-hmm.
So, Suzanne just got out of this taxi cab, okay? But she's really hungry, like really hungry. And so, she sees this burger place across the park. What route gives Suzanne the shortest distance to food?
Would be a straight line, but it's only if she's walking because there's a tree in the way.
Yes, she would cut through the park because the shortest distance between 2 points is a straight line. But what if it wasn't a park and she just knew where she wanted to go to get her burger? What if there were obstacles in her way, such as buildings? What would be the shortest distance then?
You'd have to go around them.
Yes, she would. Would you like to show us a possible route that Suzanne would take?
She would go on this, I'm assuming this is a road, so
Mhm.
she'd go here and here.
Right. So, we'll pretend that this is 3rd Street, yellow 3rd Street, and this is Green Street, okay? And so, take this block over here, okay? So we've got, Susie's on 3rd Street, and our burger joint is on Green Street over here. Okay. So she'd have to go, where'd she have to go?
She needs to go over 1 block and up another block.
Good job, because the burger joint is located at Green in 2nd.
Right.
And Susie is at Blue in 3rd.
Mm-hmm.
Good job. Okay. Is that the only way she could go?
No, she could go up and then over, so then the cab can turn around and it's not a one-way street.
Correct.
Or she
She'd
could go over 2 and up 1 and back 1.
Yeah, she could go any number of routes. Our next example shows this. Okay, so this activity is called Dispatch the Police Car. Okay? An accident has taken place somewhere in our city, and there are 2 police cars nearby that could be dispatched to the accident. Your job is to figure out which car can get there the fastest, okay? And remember that cars can only drive along the vertical or the horizontal streets on the city. As we're going through this exercise, I want you also to do it on the graph I am handing out to you, please. Okay? So, our first example, I'm going to place the police car and I'm going to place the accident and each police car at the correct points. So, the first accident is at Main and Purple. So, Main and Purple is right there. Okay, so that's our first accident. And the first police car, which is this one, you may tell me what that coordinate point is?
Main and Blue.
Good job. So the first police car is located at Main and Blue. Okay? So that's what our coordinate point looks like for the first police car, okay? And the second police car is located at where?
4th and Purple.
Good job. So we've got 4th and Purple. And where was the accident again?
Main and Purple.
Good job. Main and Purple. Okay. Now, I have a question for you. Do our points line up with the X and Y axis?
No. Yes.
You sure? Because the X-axis comes before the Y-axis, doesn't it?
Oh, yeah.
Okay, so if we have it backwards, what does that mean our accident is at?
It's a Purple and Main.
Good job. Purple and Main. Okay, so where's our police car at?
One of them is the first
The
one.
first one.
Blue and Main.
Okay, Blue and Main. And where's the second police car at?
Purple and 4th.
Good job. Okay, so that is what our coordinate points look like, right?
Yes.
That's right? Okay.
Yes.
So, what distance does the first police car have to travel before it reaches the accident?
1, 2, 3 blocks.
Right, so it has to go 1, 2, 3 blocks, right? Like that, okay? And so, how far would the second police car have to travel?
We would have to go 4 blocks up.
Right, so 1, 2, 3, 4. Good job. So class, which police car should be dispatched to the accident?
The first one because it's closer.
Very good. The first police car is 1 block closer.
No.
For the next example, the coordinates of the accident are, I'm going to give them to you. Blue and first. And would someone like to come up and place the accident in the correct spot?
Okay. This is police car number 1.
So you can leave those there. So just move the accident to where it's supposed to be.
Oh, the accident.
You're going to blue in first.
Oh, the accident. This guy's reckless driver.
Okay. And your first police car is purple and first.
Okay. Makes sense, even over here while
Okay. And your second police car is at blue and fourth.
back and forth, back and forth.
Okay, so which police car has the shortest distance to the accident?
They're the same distance, they're both 3 blocks away.
Very good. Both of the police cars must travel 3 blocks to reach the accident. Car 1 has to travel 3 blocks left, and car 2 has to travel 3 blocks up. Now, which car has the shortest route if I had 2 one-way streets? Okay, so blue is going to be one-way down, and first is going to be one way to the left. Okay, so which car has the shortest distance now?
The one at purple and first, because it only has to go 3 blocks. The one at blue and fourth would have to go over 1 block, up 3, and then over another block. So it would be 5 blocks.
Great job. It's really good math. Okay. For this example, I'm going to change all the street names to numbers. Okay?
Okay.
So that it matches with our regular grid over here, okay?
Okay.
So we're going to have 0, 1, 2, 3, 4, and 5. And 0, 1, 2, 3, 4, and 5. Okay? All these are going away. Okay?
Okay.
You're looking at the numbers in red. Okay. So, horizontal streets from left to right are 0, 1, 2, 3, 4, and 5. And vertical streets from bottom to top are 0, 1, 2, 3, 4, and 5 as well. So the accident coordinates for this example are 3, 2. Can you tell me how to find that one, Kathleen?
You're gonna go over 3 on the
1,
x-axis.
2, 3.
And then up 2 on the y.
So there?
Yes.
Okay. So the first police car has coordinates of 2, 0. Can you tell me how to find that one? Starting from here.
So you just go up 2 on the y-axis.
Here?
Yes.
Are you sure? Because, look at the coordinates again and see if you can figure out what you did wrong.
You're at 0, 2, right?
No.
No, that
2,
is
0?
not good. Really good on that.
Correct. Because the coordinates are written with the x part first, like that, okay?
Okay.
And so, if it's 2, 0, and this is the x-axis,
Oh, then it goes, start at 0 on the x and go over to
so right here.
2, and it stays there because the y coordinate is 0.
Very good. Okay. And so the second police car is at 0, 4. Can you tell me how to get there?
You go over to the, no, you just go up to the 4 on the y, because 0 is the x.
Good job. Okay, so our one-way streets disappeared. I took those away.
Okay.
Okay. Okay, so I want you to quietly figure out which car has the shortest distance to reach the accident. Yes.
The car at 0, 2,
Yes, because this car has to go how many blocks to get there?
3,
And this car has to go how many blocks to get there?
5.
Very good. Okay, so now we're going to work on an activity. I'm going to give you a worksheet, and you will complete it. And when you're finished, we're going to go over it together as a class. Okay? So, you may begin. If you have any questions, let me know, and I'll come over and assist you.
I lost my
Sorry.
pencil.
You lost your pencil.
It's down on the floor. I'll get it. What he said.
Thank you, Amanda.
Ready?
Okay.
Noah and
My
Mommy's.
pencil broke.
Your pencil broke. Oh no.
These.
Technical difficulties. Here's
They're
one.
sharp.
Here's one. Okay. Don't touch. Don't touch.
Why? I need it to be higher. Mom.
Shh.
What he said. Action. Before I stop.
First round would be
Okay, so it looks like everybody's done. Okay, so we're gonna start going over it together on the board, okay?
Okay.
Okay.
Mommy, can I play on computer?
So
She said no.
okay. Now, I have copies of the graph drawn on the board, right? Okay, so can anybody tell me what quadrants should Alice and Bruno look for an apartment in?
probably yes. The top left.
So this is 1,
Quadrant
2, 3, and 4. Okay.
Quadrant 2.
You sure? What about quadrant 1? Anything in quadrant 1?
That's not
Possibly
close
quadrant
to it.
Okay. So remember, Bruno's work is at.
Yeah, probably quadrant 1.
Here. This is Bruno, okay? So what you're going to look for is something in this general vicinity, right?
Actually,
Just something in here? That's where they want to be, right?
yes.
Okay. So So if Alice and Bruno want to find an apartment exactly halfway between their two workplaces, is it possible?
Yes.
Okay. Do you have any idea of how you could find that?
Well, they're both exactly 3 blocks off of the y-axis, so it needs to be on the y
Not necessarily.
to be halfway.
No, not necessarily. Okay, so let's count.
Won't be halfway.
These two in taxi cab distance are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks from each other. Okay? So anything 5 blocks from either workplace should be halfway, right? So we could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That one's still halfway, right?
Oh,
Or we could go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
oh,
Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or 1, 2,
yes.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right?
Okay. Yeah. Wow.
Okay. So, any of those places is halfway between their two workplaces, okay?
Okay.
And so, let's skip number C, okay?
Okay.
And we're going to go on to the school district boundary lines problem, okay?
Okay.
So let me clean up the board here. Give me a second. Okay.
Go away. Yes.
Okay. It's a little better. Okay, so for those of y'all that didn't really understand the school district problem, let's go over it together, okay?
Okay.
So we've got Fillmore High. Can anybody tell me what coordinates Fillmore High we're at?
Fillmore is at -4, 3.
So 1, 2, 3, 4. 1, 2, 3. So Fillmore High goes right there.
Yes.
Okay. Can anybody tell me where Grant High is?
2, 1.
1, 2. Grant High goes right there. Can anybody tell me where
Harding.
Harding
at
is?
-1, -4.
1, 1, 2, 3, 4. Okay. So, what do you think you do now to figure out the school district boundaries? Remember what we did with Alice and Bruno's apartments.
Okay. So count the number of blocks between schools. And then
Okay, now before we get there,
Okay.
so where do you think the school district boundary should be between the schools? Should it be here? Or here? Here?
No, it should kind of be like.
So ignore this school. Let's just look at these two, okay?
Okay,
So where do you think it should be?
so like halfway between.
Right, so if you put it halfway, then the students don't have to go a further distance to the high school,
Right.
okay? And so, how far apart are Fillmore and Grant?
Fillmore and Grant are 1, 2, 3, 4, 5, 6, 7, 8 blocks.
Okay, so how far away are Grant and Harding?
1, 2, 3, 4, 5, 6, 7, 8 blocks.
Okay, so how far away are Harding and Fillmore?
1, 2, 3, 4, 5, 6, 7, 8, 10 blocks.
Right, so the district boundary between Fillmore and Grant should lie about how many blocks from each school?
About 4.
Right. So, district boundaries should be about 4 blocks. Okay, so what about between Grant and Harding?
5.
You sure?
Oh,
Remember Grant and Harding.
Oh, I'm sorry. 4 again.
Okay, so what about Fillmore and Harding?
5.
Okay, so the school boundary will be 5 blocks from both Fillmore and Harding, and 4 blocks between these two, and 4 blocks between these two, correct?
Yes.
So, first we have to graph the points, and then we can draw the line, okay?
Mhm.
So, let's count, starting with Fillmore. For all the places within 4 blocks of Fillmore, okay?
Okay.
Between it and Grant, okay?
Okay.
So, starting here, 1, 2, 3, 4.
Okay.
1, 2, 3, 4. And is that 4? Let's check it. 1, 2, 3, 4. 1, 2, 3,
I started.
1, 2, 3, 4. Okay. So we've got 1, 2, 3, 4. Is that still 4 from Harding?
Yes.
I mean Grant?
Yes.
Alright. And this one we've got 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that's all we can do right now, is those 3 points between those two. Because otherwise you start getting into the other district boundaries, okay?
Alright.
Okay, so Grant and Harding is supposed to be 4 points as well,
Right.
correct? So 1, 2, 3, 4.
Mhm.
1, 2, 3, 4. That works, okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that one works. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now the distance between Fillmore and Harding was 10 blocks, correct?
Yes.
Okay, so our boundary has to be 5 blocks from each.
Yes.
Okay, so will these 2 points still work with both of those?
1, 2, 3. No, because it's only 4 blocks.
Well, let's see, okay? So let's start with Harding. Okay, so 1, 2, 3, 4, 5. Oh, that leaves a block without a school district there. That can't work. Okay, so let's start from over here, and we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's check these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay,
Okay.
so this one is still between Grant and Harding, correct?
Yes.
And this one is between Fillmore and Grant, correct?
Right.
So, can we connect the dots now? Will it work?
You connect this line, you have 3 different lines.
Well, remember, in taxi cab geometry, you can't cut buildings in half. Okay? So, your graph is going to look something like this. Like that. Okay? So, and this one we could actually go, we could start counting from Grant and go 1, 2, 3, 4. Here, connect the point here. Go 1, 2, 3, 4, connect the point here. Okay? And the same with over here. It would go here, connect it there. You can do that on this side too. Okay, so that's your school district boundary. Okay, and that ensures that every high schooler gets to go equidistant to the closest school. Okay?
Cool.
And so, you understand it now? Kind of?
Uh-huh.
Okay. So, Burger Barn wants to be placed exactly in the middle of the 3 high schools. Where should that be? This is Burger Barn.
Yeah.
Where should Burger Barn go?
So there's 8 blocks between those two, and 10 blocks between those, and 8 blocks between those. So
Okay, so let's just see. Let's look at, this point looks kind of in the middle, right?
yeah.
Okay, so let's count. 1, 2, 3, 4. Okay, so then we've got 1, 2, 3, 4, 5, 6. Uh-oh,
No.
that doesn't work. Okay, 1, 2, 3, 4. It's close. So you've got 6 and 2 4s. Where could I move it to where it could be 3 5s?
Move it over to minus
So this
2.
one?
Yeah. I think
So negative 2, 0.
Uh-huh.
So we've got, let's put it there. 1, 2, 3, 4, 5.
Uh-huh.
1, 2, 3, 4, 5. Looking good. 1, 2, 3, 4, 5. Good job. Cool. Okay. So let's go back to 1C. Okay?
Okay.
And we're going to do that one on the grid, even though there are other things there, because cities are full of things. Okay?
Right.
So the accident is at, okay, the accident is, can anybody tell me where the accident is at?
Minus 1, 4.
Okay, so you've got negative 1, 1, 2, 3, 4. So that's our accident, okay?
Yeah.
Where is police car 1 at?
At 1, 2.
Okay, so 1, 1, 2, and where's police car 2 at?
At minus 1, 1.
Right there. Okay, so which police car should be dispatched to the accident?
2.
2?
Mm-hmm.
Why?
Because he's 3 blocks from the accident.
Right, so he only has to go 3 blocks up. Whereas car 1 has to go, 2 blocks up and 2 blocks left. Okay? But what if they were helicopters and not police cars and they weren't bounded by the city streets?
Then car 1 would be closer. I mean, helicopter 1 would be closer because it could go, it would be only 2 blocks.
Right. Well, it's not actually 2 blocks. It's a formula, which we're going to learn later. But
Oh.
so since they're helicopters, this one only has to go a slightly shorter distance than this one.
Right.
They're still pretty close, but this one has a shorter distance to go. Okay? So as I said at the beginning of a lesson, the shortest distance between 2 points is a straight line, correct?
Yes.
Okay. So instead of having to do a zigzag as a car, it can just go straight across as a helicopter, right? Okay, so this one you're going to go later in depth into your math career, okay? So today we talked about a new kind of graphing called what?
Taxi cab geometry.
Okay, can anyone tell me what the difference between this kinds of graphing and regular graphing are?
You can't cut buildings in half.
Well, true.
You can't go diagonal. But in regular graphing, we can draw diagonal lines, and like we did transformation with triangles.
Right. In taxi cab geometry, you can't cut through buildings. It
Right.
doesn't work. Okay, so you can't go in diagonal lines because the buildings are in the way. But in regular geometry, you can, as like Susie said, we did when we did transformations. So can anyone tell me the distance between points? Let's see, we're gonna do great experience on it. Okay, between points A, that one A, and this one B. Okay, so what is the distance in between A and B?
4.
All right, let's count that to make sure. Okay, so 1, 2, 3, 4. Good job. It's 4. So the distance between these 2 points in taxicab geometry is 4.
Mm-hmm.
Now, what if I were to ask you what the distance between these 2 points in regular geometry is?
It would be the rise over the run.
No, that would be the slope.
That'd be the slope.
But that's a question I'm going to give you to keep your brain chewing on. Okay? And so tomorrow, we're going to discuss the geometry of some fairly common shapes in taxicab geometry. Your homework is to think about how you could use taxicab geometry in the real world. And we'll discuss that as part of our warm-up tomorrow. It's a great job, class, today.
Cool.
You're awesome.
How do you make it stop?